Today we are learning the third and final method of solving systems of equations. This is the second of our three methods where we solve this algebraically. The first way that we learned was graphing them. So we solved them for y equals mx plus b, and then we graph them. And remember, we're looking for where these two lines intersect. All right, sometimes they don't intersect, so they'll be parallel, so that means there's no solution. Sometimes when we solve them, they actually end up being the same line. So this would have infinitely many solutions. But most of the time, we're going to have one solution. And remember to state your solution as a coordinate. So today we're going to do the elimination method. The elimination method is exactly how it sounds. What we're going to do is we are going to combine both of the equations and actually eliminate one of the variables in order to solve. So if we look through this step-by-step procedure that we're going to do each time, the first thing we're going to do is we're going to add or subtract to eliminate one variable. Once we go through all the examples, you'll understand what I mean by that. Then what you're going to do is you're going to solve for that remaining variable. Once you do that, just as you did with the substitution method, you are going to put that solution back into one of the original equations to solve for the last missing variable that you have, and then finally state the solution. Again, this is if you were to graph these two linear equations, this would be where they intersect. And then lastly, you can check. If the question does not say to check, you do not have to, but remember, doing the check is a great way to make sure you get full credit. Sometimes you might make a really simple algebraic error, so when you check, you'll make sure that that doesn't happen. So the goal of this is to get one equation with one variable. So with substitution, we actually solved for one of them and then replaced it into the second equation. What we're going to do here is we're actually going to either add or we're going to subtract. So if we are adding, we are going to be looking for additive inverses. Remember, additive inverses are opposites. Okay, that is the same exact thing. All right. So for example, if I had negative 4x and 4x, these are additive inverses because when I add them together, they equal 0. All right. Now the same thing goes for subtraction. If I have the same thing, so let's say I have a negative 4x and a negative 4x, if I were to do negative 4x minus negative 4x, that's basically like adding. Remember, we have to add the opposite. So that would still equal 0. And again, the purpose of this, the goal is to get to eliminate one of the variables. All right, so example number 1, and I have the steps right there for you so you can use those. So what we are looking for is we are looking for either the same variable in each of them, or we're looking for the additive inverses. Just by looking at this, I already noticed that I have additive inverses. Okay? So all this means is that I'm going to use addition. Okay? Think additive inverses. Additive starts with an A. Addition starts with an A. So what we're going to do is we're going to add both of these equations. All right? When we do that, we get 5x. These cancel out. Okay? Remember, there's a 1 in front of the y, so it's negative 1y plus 1y, so those will cancel out. So this is equal to 25. Divide both sides to solve for x, and then just like in the other, in the substitution method, you're just going to plug that back in. You're just going to substitute that back in. So I'll do 2x minus y equals 10. And I'll plug that in. negative y equals 0, so y equals 0. So my final answer is 5, 0. And there's my check. Okay, so not that much different than the substitution method. We're still only solving for one at a time. But again, instead of plugging one into the other, we're actually going to eliminate one of them. So we're going to actually add them or subtract. So now this one, you could actually add or subtract, because if you look, x and x are the same. So if I did subtract them, that would work. But it's always easier to add. So I'm actually going to add. Now remember, you can't always add, but I have the option here because my x's are the same, so I would subtract. My y's are additive inverses, so I would add. So I'm going to choose to add. So I get 2x, my y's cancel out, equals 16, divide by 2, so x equals 8. Don't forget to substitute back in. Remember, this is a coordinate. We're always looking for a coordinate. So x plus y equals 12. Also, don't forget that it does not matter which one you substitute back in. We are looking for a solution to both of them. So regardless of which one you choose, you will get the correct answer. Alright, so my final answer I get is 8, 4. Also, don't forget, double check what your solution looks like. I solved for x first and then y, so my order stays the same, but sometimes you might do it the other way around. So just take that extra second to make sure you write your coordinate correctly. I would hate to take off even a little bit of your points just because of that. And again, there's the check. Okay, again, very similar. I'm going to choose to add. Whenever I have that choice, I'm always going to add. Again, I have the A's are the same, so I would subtract if I wanted to, but my B's are additive inverses, so I'm going to choose to add. So 2A equals 18. Divide both sides by 2, so A equals 9. So 9 plus B equals 13. Sure, so you could just do that in your head. So B equals 4. So my final answer is 9, 4. Remember, when you don't have x, y, you always do it in alphabetical order. Always, always, always. They don't have to tell you to do that. Sometimes they do tell you to do that, but if they don't, just assume that it has to be in alphabetical order. Okay, so now we have one where we're going to have to subtract. Okay, so I see that I have 2 y's in my equations. Remember, we're looking for their coefficients. The coefficient is just the number in front of them. So I have a 3, a 2, and then I have both of these are 1s. So what I'm going to choose to do is I'm going to choose to subtract. Now, when you subtract, here's the thing. Now, I always put parentheses around this, because what you're actually doing is you're bouncing. You're doing 3x minus 2x, y minus y, 16 minus 11. So what I do is I actually rewrite this as an addition problem. So when I subtract integers, I usually call subtracting adding the opposite. Okay, and here's why I do this. So if I subtract, adding the opposite is the same exact thing. So what I'm going to do is I'm going to rewrite the first equation because that's not going to change. But the second equation, I'm going to switch to addition. I'm going to keep my parentheses around it. And then every single term, I'm actually just going to write the opposite, or the additive inverse. So they're all positive numbers, so I'm going to change them all to negatives. So what I've done is I've just made it a lot easier to look at. If you can do it just by subtracting, just make sure you subtract like terms, and you have to subtract all the way down. Okay, so by doing what I've just done, you can just kind of make sure that you definitely do this correctly. So I get x, my y's cancel out, equals 5. X equals 5. So by the end of this week, you guys will have learned 3 different methods. You'll have your quiz. What I want you to notice is I know that you're going to have a favorite. If the directions don't specify, use the method that you like the best. We're also going to learn which method is the best one to use. It doesn't mean you have to use that one. It just means that it will take probably the less time to do it. But all of these methods, the 3 methods, graphing, substitution, and elimination, they all work for every problem. Again, some of them are just a lot easier than the other. And we'll talk about that in another lesson. Okay, remember, if I'm going too fast, just make sure that you pause. If I'm going too slow, fast forward. All right, so here we have what looks to be like a very confusing problem. But what we know about math is that we can always rearrange equations. Okay? Even when we're solving, we're basically just rearranging our equations to make it look a little nicer. So what I notice is the first equation is written with the x in front. The second equation is written with the y in front. So I'm just going to reorganize this to get a better look. So I see that I can cancel my x's out. All right? And they are the same, so I'm actually going to be subtracting. Okay, I'm going to be subtracting. So I am going to rewrite this. Again, I don't like subtracting. I think it's easier to add the opposite. And if you have no trouble subtracting, then by all means, please keep it and just do what you do normally. Okay, so all I did was I went through and I changed all of the signs. This is the same exact thing. Remember, a negative with a negative becomes a positive. So I'm subtracting a negative, that's really adding. I'm subtracting a positive, so that means I'm subtracting. And then I'm subtracting a negative, that's the same thing as adding. So now I have a nice easy problem right here. I get negative 10y is equal to 10. So y equals negative 1. So here is what I was talking about before. I solved for y first. So now I'm going to be careful, and when I write my final solution in a minute, I'm going to make sure that I write it in the right order. So substitute your y in. Oops, sorry, that came out awful. All right. Be careful with your signs. Sorry, I skipped a step. I just subtracted 8 from both sides. All right, so my final answer is 7, negative 1. 7, negative 1. All right, just a few more questions. All right, so for the first one, for number 6, I do see that I have a 4x and a 4x. So subtraction would be the best for this one. I'm not going to rewrite it. I'm going to try to do it just this way and see if you guys like it that way as well. So again, I'm going to bounce back and forth between this negative sign to make sure that I get this all right. So 4x minus 4x, that cancels out. 2y minus 8y is negative 6y. 12 minus a negative 24 is actually changes it to addition, so I would get 36. divide both sides by -6, so y equals 36. Let's substitute that back in. So 4x plus, oh, losing it. Sorry, that's a -6. Trying out a new microphone today, so make sure you let me know in class if it's any louder. It's literally like up against my face. All right. So 4x minus 12 equals 12. All right, so x equals 3. The final answer for that one is 3, -6. All right, the next one, we're just going to add those two together. Oh, that's way too bright. Let's try a different green. Okay. So when I add them together, I get 11x is equal to -16 plus 5, -11. So x equals -1. So I'm going to do the second one. That looks pretty easy. -1 minus y equals 5. -3 minus y equals 5. So y equals -8. So my final answer for that is -1, -8. All right, and the last two, I'm going to show you the answers for these for sake of time, but I will talk about both of them. So for number 8, I see we have additive opposites, so I'm going to add. And for number 9, I see I have the same, so we're going to subtract. All right, so there's those final two answers. All right, so again, what we're going to talk about later on in the chapter is how to know which is the best method to use. Sometimes the directions will specifically tell you to solve by graphing, solve by substitution, solve by elimination, but sometimes it's just going to ask you to solve. More often than not, it's going to specify if they want you to do it graphically or algebraically. Remember, if it's a multiple choice question, do it in the graph. That's probably the easiest, unless it's blatantly could be an elimination problem and you can just add them really quick. You're really I'm gonna try to do enough examples so that you guys can use your best judgment in figuring out the best of the three methods to use.